The year 2025 passed surprisingly fast, and it was anything but quiet. Today, we'll look back at the key events, try to make sense of what actually happened, and cautiously speculate about what might be waiting for us in 2026. Let's start right at the beginning of the year. January set the tone almost immediately. On the 20th of January 2025, the DeepSeek R1 model was released. Back in 2024, the Chinese startup DeepSeek had already attracted attention, but it was the R1 version, their reasoning model, that turned it into a global phenomenon. For nearly a month, international media described DeepSeek as a breakthrough, largely because of its claimed training costs, allegedly hundreds or even 1,000 times lower than those of models like ChatGPT or Claude. And this, despite the fact that R1's capabilities were, at least on paper, not dramatically inferior to Western counterparts. However, as is often the case, the euphoria didn't last long. Additional details soon emerged, suggesting that the Chinese miracle might not be quite so miraculous. Some experts began to suspect that the true costs behind R1 were being deliberately obscured, either for marketing hype or for broader political reasons. Whether these suspicions are justified remains unclear, but the importance of R1 lies elsewhere. Its release effectively confirmed a new industry standard. By early 2025, it became obvious that reasoning models were no longer an experimental feature. They had become a baseline expectation and the primary direction for every serious chatbot. And this trend would define much of the year. Around the same time, Tesla unveiled an updated version of its humanoid robot, Optimus. The new model demonstrated faster walking, improved balance, and noticeably better hand dexterity. Tesla announced that deployment at its factories was only months away, with robots expected to participate directly in vehicle assembly. Whether this timeline was realistic or overly optimistic was still an open question. But the message was clear. Humanoid robotics was moving from demos to production environments. Toward the end of January, OpenAI released GPT-o3 Mini. This compact reasoning model reached performance levels comparable to O1, the first reasoning model introduced just months earlier, which had produced striking results across many benchmarks. The key difference was efficiency. O3 Mini delivered similar capabilities while being faster and significantly cheaper to run. This optimization made it possible to offer limited access even to free ChatGPT users, signaling an important shift. Advanced reasoning was no longer reserved exclusively for premium tiers. So, January became the month when reasoning models turned from a rare premium feature into something relatively affordable and accessible to almost everyone. And this happened less than 6 months after the release of the very first such model, O1. In the same month, OpenAI, Oracle, and Microsoft announced the launch of the Stargate project. This is a massive network of purpose-built data centers designed specifically for large-scale AI workloads. In total, more than 20 data centers are planned across the United States, with a combined capacity and power consumption exceeding 10 gigawatts. To put that into perspective, this is roughly 1.5 times the average daily electricity consumption of New York City. Construction on the first Stargate facilities began immediately in January, leaving little doubt about how serious this investment is. February continued the acceleration. Andrej Karpathy, one of the world's most influential figures in machine learning, introduced the term vibe coding. This is how he described a new style of programming in which you simply describe what you want in natural language, receive working code generated by a neural network, and then run it without ever touching traditional syntax. The term spread so quickly and became so culturally recognizable that later in the year, in November, the editors of the Collins Dictionary named vibe coding the word of the year. On February 5, Google made Gemini 2 Flash available to all users and developers. Its context window jumped from 128,000 tokens to 1 million, which was an enormous gift for developers working with large codebases and complex documentation. Multimodal capabilities were also noticeably improved, allowing the model to work more effectively with images, video, and audio. And, as expected, all of this came alongside higher speed and stronger reasoning performance. February was also notable for developments in robotics. Figure AI unveiled Helix, a prototype humanoid robot designed to assist with household tasks. The company made it clear that it is aiming not only at industrial or commercial applications, but eventually at the consumer home market as well. The startup 1X shares this vision. It introduced its own household robot, NeoGamma. However, Neo Gamma became famous less for technological breakthroughs and more for the flood of memes it generated online, which, in a way, is also a sign of public interest. Then, on February 17, Elon Musk's company, xAI, released Grok 3. This version placed a strong emphasis on advanced reasoning modes, making them genuinely useful for deep mathematical and scientific analysis. It also added an integrated internet search mode for working with up-to-date information. What makes Grok 3 especially noteworthy is how it was trained. For the first time, xAI used the Colossus supercomputer, a system built from roughly 200,000 NVIDIA H100 GPUs. As a result, Grok 3 required around 10 times more computational power to train than its predecessor. 200,000 graphics cards for a single model. This number alone perfectly illustrates the insane race for computing resources that I've talked about many times before. And now you know exactly why GPUs and RAM have become so expensive. On February 24, Anthropic released Claude Sonnet 3.7. At the time, it was widely regarded as the most intelligent, publicly available model and, importantly, the first true hybrid reasoning model on the market. The overall pattern was already familiar by then: stronger performance across a wide range of tasks, improved reasoning, multiple operating modes, and very impressive results in programming benchmarks. But Claude 3.7 stood out precisely because it blurred the line between fast generative models and slower, more deliberate reasoning systems, showing that these approaches could coexist within a single architecture. That same month, Microsoft introduced 5.4 multimodal. This model was designed to process text, images, and audio within a single unified architecture, without the need to stitch together multiple specialized models for different data types. 5.4 did not dominate benchmark charts, but it compensated with three very practical advantages. First, it was compact enough to run even on consumer-grade hardware. Second, it offered a solid context window of 128,000 tokens. And third, and arguably most important, it was released as open source with publicly available weights. For many developers, this made 5.4 far more valuable than models that scored higher on tests but remained closed. March marked a noticeable shift in the global balance of the AI race, as major Chinese companies began entering the mainstream in a serious way. Alibaba launched Qwen 32B, a reasoning model with 32 billion parameters. According to the company, it outperformed OpenAI's O1 Mini and competed directly with DeepSeek R1, which at the time was considered the most powerful open-source reasoning model. Shortly after that, Baidu unveiled two major releases. ERNIE 4.5 was presented as a general-purpose model with basic reasoning and multimodal capabilities, while ERNIE X1 Turbo was designed specifically for deep reasoning tasks that require complex, multi-step thinking. ERNIE 4.5 reportedly surpassed GPT 4.5 several benchmarks while operating at significantly lower training and inference costs, a claim that drew considerable attention across the industry. At NVIDIA's GTC conference in March, the company's CEO unveiled the Blue character robot, developed in collaboration with Disney Research and Google DeepMind. This presentation was important, not because of raw performance numbers, but because it demonstrated something different. AI controlling a physical agent with smooth, expressive, almost lifelike motion, rather than behaving like a rigid, industrial manipulator. It was a glimpse of what embodied AI might eventually look like outside factory floors. Google, meanwhile, surprised everyone once again. Just 48 days after releasing Gemini 2, the company launched Gemini 2.5 Pro in an experimental version. The new model showed a clear leap in productivity, achieving strong results in reasoning, code generation, and multimodal understanding. Many users noted that its responses felt noticeably more natural and human-like compared to previous Gemini generations. The context window was expanded to 1 million tokens, matching what had already been done for Gemini Flash, and overall, the model proved highly capable at solving logical problems and writing code. For most of the remainder of the year, Gemini 2.5 Pro would remain Google's flagship model. It consistently made competitors nervous and gradually pulled users away, even from ChatGPT. In my subjective opinion, this was the moment when Google stopped playing catch-up in the chatbot race and firmly moved into a leadership position. Figure AI announced the launch of BotQ and revealed that its factories are designed to produce up to 12,000 humanoid robots per year. This was an important signal. It suggested that the industry was beginning to move away from isolated prototypes and laboratory demonstrations toward genuine mass production of humanoid machines. April became one of the densest months of the year in terms of major releases. On April 4, Meta introduced Llama 4 Scout and Llama 4 Maverick. These were the company's first open, natively multimodal models, capable of processing text and images within a single unified architecture, without auxiliary modules. What truly stood out was the context length. Scout supported up to 10 million tokens, while Maverick offered 1 million. To put that into perspective, 10 million tokens correspond to roughly 15,000 pages of text. However, despite their scale and multimodal nature, these models did not include a dedicated deep reasoning mechanism, focusing instead on breadth, speed, and context handling. Around the same time, Midjourney released version 7, its first major update in almost a year. The improvements were immediately noticeable. Stronger photorealism, significantly better hands and facial anatomy, improved prompt understanding, and more reliable text rendering within images. For many creators, this update marked another quiet but decisive step toward blurring the line between generated and photographed content. On April 16, OpenAI released the O3 and O4 mini models to all users. O3 represented the next generation of reasoning models, trained to think longer and more deeply, achieving stronger results in multi-step reasoning across mathematics, science, and programming. As expected, at the time of release, it topped a wide range of benchmarks and, somewhat humorously, outperformed most AI-focused YouTube channels in raw analytical depth. Alongside it, O4 Mini was introduced as a more compact successor to O3 Mini. It preserved reasoning capabilities while remaining fast and relatively inexpensive, making it far more accessible for everyday use. The very next day, on April 17, Google rolled out Gemini 2.5 Flash in an experimental release. Compared to its predecessor, the model demonstrated improvements in performance, comprehension, and reasoning, which could be activated on demand. Instruction following was also noticeably better, reinforcing Flash's role as a fast, responsive model for both developers and general users. May was defined by Google's annual I/O conference, held on May 20. As expected, the company unveiled a new wave of generative models. Imagen 4 was introduced for image generation, while Veo 3 became the centerpiece of the event as Google's next-generation video model. It was Veo 3 that triggered the explosion of pseudo-realistic shorts that flooded YouTube over the summer. Beyond producing highly detailed video, the model generated background sounds and even speech, enabling the creation of complete, self-contained video clips. Will Smith eating spaghetti would certainly approve the progress of video generation over just 2 years has been nothing short of remarkable. On May 22, Anthropic introduced Claude Opus 4 and Sonnet 4, new hybrid reasoning models supporting context windows of up to 200,000 tokens. They continued the trajectory set by earlier versions, offering 2 distinct modes of operation: fast responses for everyday tasks and deep reasoning for more complex problems. By this point, Anthropic had clearly carved out its niche. Its models were firmly associated with programming and long-form creative writing. The company seemed to fully recognize where its strengths lay and doubled down on usefulness for developers. At the same time, many users working with advertising, copy, scripts, or text-based role-playing games gravitated toward Claude for its more human, and in some cases even emotionally richer, style of responses. Around the same time, the little-known company Loki unveiled a humanoid robot designed specifically for cleaning rooms. It looked less like a futuristic science fiction machine and more like a logical next step in the evolution of robot vacuum cleaners, only now with legs and arms. On May 29, French startup Mistral AI released several models simultaneously: Medium 3, Codestral, and Document AI, aimed at basic multimodal tasks, programming, and enterprise document workflows. Overall, Mistral faded somewhat into the background in 2025, especially amid the intense competition between Google, Anthropic, and OpenAI. Still, it remained one of Europe's largest AI startups, continuing to attract funding and likely channeling it into highly specialized, domain-specific models rather than general-purpose flagships. June turned out to be one of the quietest months in the AI industry, with no truly headline-grabbing releases. Google launched Gemini CLI, an open-source AI agent designed to work directly inside the terminal. clearly targeting developers. At the same time, Flash Lite was introduced, an extremely fast and inexpensive model intended for simple tasks like translation or text decoding, signaling a push toward lightweight, utility-focused AI services. Figure showcased its O2 robot, trained to sort trash. The demonstration videos revealed noticeable improvements in fine motor skills, suggesting steady progress toward practical, real-world deployment. Tesla, meanwhile, released a video showing a Model Y delivering itself directly to a customer. With this demonstration, the company once again emphasized that fully autonomous driving, at least in urban environments, was approaching maturity. Tesla also announced the first official launch of its own robotaxi service, reinforcing the idea that autonomy was no longer a distant promise but an imminent commercial reality. July marked another escalation. Just 5 months after releasing Grok 3, xAI rolled out Grok 4. As expected, improvements were made across multimodality, reasoning depth, and general performance. By this point, such upgrades had become almost routine, with nearly every major release pushing the same metrics forward. Grok 4 expanded its context window to 265,000 tokens and introduced a new, heavy, multi-agent mode where multiple models work in parallel on the same problem to improve answer quality. A specialized programming version, called Grok Code, was also released, offering stronger performance in writing, debugging, and understanding code. In certain benchmarks, Grok 4 briefly outperformed competitors from OpenAI and Anthropic, though, as had become typical in 2025. Such leads rarely lasted long. And then there was X's most controversial release of the year, Ani, the company's first virtual companion. Marketed as an AI girl with a visual response system and even an adult mode, Ani came in various stylized avatars, anime characters, foxes, pandas, and allowed users to interact via voice or text. More than a technological breakthrough, Ani felt like a cultural signal, hinting at how quickly AI was moving beyond tools and into deeply personal and sometimes unsettling forms of interaction. UB Tech demonstrated its Walker S2 humanoid robot, capable of replacing its own battery without human assistance. It's a simple idea, but an extremely practical one. At least in industrial environments, this approach could solve one of the biggest bottlenecks of robotics: downtime. A robot that can maintain its own operation without stopping production is no longer a prototype curiosity, but a genuinely scalable solution. Google DeepMind released Alpha Genome, a specialized AI system designed to interpret the human genome. Unlike language models that operate on text, Alpha Genome works directly with DNA sequences, predicting how genetic variations affect gene regulation, expression, chromatin structure, and other fundamental biological processes. Together with AlphaFold, this marks another step toward what could be called biological AI systems that don't just describe biology, but actively help us understand and model life at the molecular level. Alibaba presented Qwen 3, the next generation of its open-source model with improved reasoning and multimodal capabilities. By July 2025, Qwen 3 ranked among the top 5 language models in several independent benchmarks, reinforcing China's position not just as a follower, but as a serious competitor in open AI development. Meanwhile, the AI-powered search engine Perplexity released its own web browser, Comet. Unlike traditional browsers, Comet integrates agent-like capabilities, allowing it to analyze information, summarize content, and automate tasks directly in response to user requests. This signaled a broader shift toward browsers becoming active participants rather than passive windows into the internet. August. At the beginning of the month, Anthropic introduced Claude Opus 4.1, an incremental but important update focused on agent-based tasks and advanced programming workflows. The release came against the backdrop of remarkable business growth. Anthropic's annual recurring subscription revenue jumped from $1 billion to $5 billion in just 7 months, highlighting the rapidly increasing demand for high-end reasoning models. On August 7, OpenAI released the long-awaited GPT-5. Nearly 2.5 years had passed since the launch of GPT-4, making this one of the most anticipated releases in recent AI history. GPT-5 became OpenAI's most capable model to date, leading in both reasoning depth and general knowledge, with noticeably more adaptive and flexible thinking compared to GPT-4.5. Public reaction was mixed, but for reasons few had expected. Regardless of the debate, benchmark results confirmed that OpenAI had achieved a genuine technical breakthrough. Around the same time, Google DeepMind unveiled Genie 3, a universal generative AI capable of creating fully interactive virtual environments from a single text prompt. Unlike traditional game engines or simulations, Genie 3 generates entire worlds on the fly, allowing users to explore, modify, and reshape them in real time through natural language. It was one of the clearest demonstrations yet of AI moving from content generation to world generation. Unitree announced the start of sales for its affordable humanoid robot, the Unitree R1, priced at approximately $5,900. For the first time, a humanoid robot crossed a psychological threshold, moving from industrial showcases and research labs into the realm of consumer-accessible technology. Around the same time, the International Federation of Robotics published an analytical report that explicitly described humanoid robots as the next major step in automation, emphasizing China's role as both the largest manufacturer and the largest market for industrial robotics. This was a clear signal that humanoids are no longer a speculative future, but an emerging industrial reality. Toward the end of the month, Google released Nano Banana, a flagship model focused on image generation and, more importantly, image editing. Nano Banana allows users not only to create photorealistic images, but also to modify existing photographs with remarkable precision. Small details can be changed, damaged images restored, and even multiple photos merged into a single coherent scene, all through a single text prompt. In the past, suspicious images were dismissed with the phrase, "It's Photoshop." Now, a new phrase is emerging. It's Nano Banana. Google also released Gemini Nano for local deployment on Pixel smartphones. This marked an important shift toward on-device AI. Simple tasks can now be handled directly on the phone without an internet connection, while more complex requests are delegated to the cloud. AI is no longer just something you access, it's something you carry with you. At the same time, Google began aggressively integrating AI features directly into its search engine, effectively absorbing functionality that had previously been the domain of specialized AI search tools like Perplexity. September. ByteDance introduced Seedream 4, a comprehensive system for generating and editing images, widely seen as a direct competitor to Google's Nano Banana. The tool combines image creation and modification in a single workflow, allowing users to generate posters, infographics, and photorealistic visuals entirely from text prompts. Anthropic released Claude Sonnet 4.5, positioning it as the world's most capable coding model. It demonstrated the ability to operate autonomously for over 30 hours, achieved an 84% reduction in token usage during context editing, and reportedly reached a 0% error rate in certain code editing benchmarks. This reinforced Anthropic's reputation as a leader in developer-focused AI. OpenAI launched Sora 2, a significantly improved video generation model, accompanied by the release of a dedicated social platform for creating and sharing AI-generated videos. Compared to the original Sora, the new version showed major improvements in motion realism, visual consistency, and adherence to user instructions, pushing AI video generation closer to mainstream creative use. Apple released a major update to Apple Intelligence across its devices. One of the most notable features was live translation, enabling real-time text and voice translation in messages, FaceTime, and phone calls. This, quietly but profoundly, changed everyday communication, especially across language barriers. Alibaba introduced Qwen 3 Max, a flagship model with approximately 1 trillion parameters. It supports both standard and reasoning modes, processes up to 260,000 tokens, and includes tool calling capabilities. The model demonstrated strong performance in coding, complex reasoning, and agent-based tasks, placing it firmly among the most powerful models of the year. Google DeepMind unveiled the Gemini Robotics 1.5 family, marking a decisive step into the era of physical AI agents. These models allow robots to perceive their environment, plan actions, reason through multi-step problems, and use tools with significantly greater competence than previous generations. Robotics was no longer just about movement, it was about cognition. Microsoft announced the Fairwater AI Superfactory project in Wisconsin, described as the most powerful AI data center ever planned. Scheduled for completion in 2028, the project underscored how AI progress is increasingly constrained, not by ideas, but by infrastructure, energy, and compute. October. In mid-October, Anthropic released Claude Haiku 4.5, the fastest model in the Claude family, featuring around 10 billion parameters. It was optimized for tasks requiring high-quality responses with minimal latency, such as summarization, classification, and rapid text comprehension. NVIDIA unveiled Nemotron 4, a massive 340 billion parameter model designed specifically for synthetic data generation. As discussed in previous videos, the exhaustion of high-quality training data has become a serious bottleneck for AI development, with most models having already absorbed nearly the entire public internet. Nemotron addresses this problem directly by generating high-quality synthetic datasets to train other AI systems, effectively turning data scarcity into a solvable engineering problem. In October, Google AI announced the launch of an oncology AI model, a system designed to accelerate the discovery of cancer treatments. The model uses generative biosimulation to analyze molecular interactions and identify promising therapeutic candidates. Early results indicate a noticeable increase in accuracy when predicting how different therapies interact in oncology trials. This was another clear example of how AI in 2025 increasingly shifted from consumer tools toward deep scientific and medical applications. That same month, OpenAI launched the Atlas web browser, a new browser with deep integration of ChatGPT. Atlas is designed not merely for browsing, but for action. It can perform complex, multi-step tasks such as booking tickets, conducting deep research, comparing options, and executing workflows directly within the browser environment. This marked a step toward AI-native interfaces, where artificial intelligence is not an add-on, but the core of how users interact with the web. In November, xAI released Grok 4.1, an improved version of its model with enhanced reasoning capabilities and tighter integration with the X platform for real-time data access. According to published benchmarks, the model demonstrated performance approaching 89% in selected evaluations, reinforcing xAI's focus on real-time, context-aware reasoning tied directly to live information streams. OpenAI introduced GPT-5.1, an upgraded version of GPT-5 featuring two distinct operational modes. The Instant mode is optimized for dialogue, offering fast responses with adaptive reasoning, while the Thinking mode allocates computational resources dynamically for deeper, more complex reasoning tasks. According to OpenAI, GPT-5.1 became noticeably warmer in communication, more reliable at following instructions, and faster overall, refining the balance between intelligence and usability. Google, however, delivered what many considered the most disruptive release of the month with Gemini 3 Pro, the flagship model of the new Gemini generation. Gemini 3 Pro significantly outperformed competitors in visual and multimodal tasks, handling text, images, audio, and video simultaneously with remarkable coherence. It showed especially strong results in image and video understanding, programming, mathematics, and even scientific reasoning. Alongside it, Google introduced the Anti-Gravity Service, an interface for deploying autonomous agents capable of planning, executing, and verifying complex programming tasks end-to-end. At the same time, Nano Banana Pro was unveiled, an enhanced version of Google's already powerful image generation and editing model. The Pro version supports image generation at resolutions up to 4K and demonstrates improved text handling, further blurring the line between real and synthetic visual content. China's Moonshot AI released Kimi K2, a competitive model whose performance closely rivaled leading Western systems. While it fell slightly short in some benchmarks, its open-source nature compensated for these gaps, making it an attractive option for developers and researchers. Google DeepMind also introduced Sima 2, a new generation of Gemini-based AI agent designed to operate inside virtual environments. Sima 2 can function within complex 3D games and simulated worlds by analyzing raw visual input, the screen itself, and acting through a virtual mouse and keyboard, just as a human player would. The agent understands high-level goals, breaks them down into tasks, builds action plans, and reasons about its behavior rather than simply reacting. It also demonstrates strong self-learning abilities and can transfer skills between different virtual worlds. In essence, this represented another concrete step toward AGI. A system that learns to act in virtual environments using perception alone could, in principle, be transferred to robots operating in the physical world. December. On December 1, DeepSeek released version 3.2 of its model, featuring an impressive 680 billion parameters. In several benchmarks, the model achieved performance comparable to GPT-5 and Gemini 3, particularly in mathematics and coding tasks. Unlike many of its top-tier competitors, DeepSeek 3.2 remained fully open source, reinforcing China's growing role in the open AI ecosystem and closing the year with one of the most notable releases in terms of scale and accessibility. The Times published a report highlighting the explosive growth of investment in humanoid robots. According to the publication, in 2020, the total investment in this sector amounted to just $42 million. By 2025, that figure had grown to $2.8 billion. The conclusion is clear. The market increasingly believes in the future of universal humanoid robots and is willing to invest heavily in their development. After the release of Gemini 3 Pro, an update with which Google, quite frankly, overwhelmed its competitors, OpenAI declared an internal red alert and redirected enormous resources toward the rapid release of GPT-5.2. The company expanded the context window, significantly improved reasoning, and strengthened agent-based capabilities, and this time, the result matched expectations. Version 5.2 is what GPT-5.0, released in August, was supposed to be. Unlike the somewhat vague and controversial summer launch, GPT 5.2 delivered consistently strong results, both in benchmarks and in real-world use. OpenAI managed to reclaim its leadership, at least temporarily. Shortly after that, Google released Gemini 3 Flash, a model that surpassed the previous flagship Gemini 2.5 in speed, reaching up to 218 tokens per second while reducing token usage by as much as 30%. This made it especially attractive for real-time applications where performance and efficiency matter more than raw intelligence alone. xAI announced the construction of a massive 500-megawatt data center in Saudi Arabia. Looking at the global picture, the total declared value of data center projects announced in 2025 approached $61 billion. Infrastructure, not models, increasingly became the true bottleneck of progress. Waymo reported a 50% increase in its robotaxi fleet over the year. According to the company, its vehicles now complete approximately 450,000 fully driverless trips every week. Waymo plans to expand not only within major U.S. cities, but also internationally, with launches in London and Tokyo planned for the near future. So, let's sum it up. Of course, these are far from all the events that took place in 2025. News of varying importance appeared almost daily, and it would be impossible to fit everything into a single video. At first glance, the year may seem less dramatic than the previous one, but that impression is misleading. What truly stands out is the pace. New model generations or major updates appeared every 3 to 6 months. Imagine flagship smartphones being released quarterly instead of annually, each time with noticeable improvements. In computational terms, it felt as if we had jumped from an Intel 486 to a Pentium 2 in a single year. In my view, everything that happened in 2025 was the logical continuation of processes that began in late 2024. Developers extracted nearly all remaining potential from last year's breakthroughs. Reasoning models were refined and optimized throughout the year, while multimodality matured to the point where neural networks could reliably see and hear, not just read text. The first truly functional browser-based AI agents became available. Just 3 years ago, many people encountered a chatbot for the first time, one that could answer questions, often incorrectly. Today, those systems independently search for products, book tickets, and execute multi-step tasks. Programming-focused agent systems made especially significant progress. Professionals now write code faster, even accounting for debugging and error correction. More importantly, people with no technical background can create websites, simple games, and basic software products. And finally, the massive data centers that were funded just a year and a half ago began not only to break ground, but to come online. 2025 wasn't a year of a single dramatic breakthrough. It was the year when everything quietly started to work. Robots have significantly improved their coordination and fine motor skills, and developers have released a growing ecosystem of simulation software that allows robots to be trained in virtual environments before being deployed in the real world. Throughout the year, autonomous robotaxis continued to launch across different countries, and their fleets expanded month by month, gradually becoming part of everyday urban infrastructure. As I mentioned in a recent video, leading AI researchers themselves openly acknowledge that most of the straightforward techniques for scaling and improving existing models have already been exhausted. This means that in the near future, companies will be forced to return to fundamental research and genuinely new ideas if they want to keep pushing AI forward. As we've seen, Google seems to understand this better than anyone. I would even go so far as to call it the year of Google. This was the moment when the company stopped lagging behind other chatbot developers and, in many areas, began to surpass them. Google rolled out an entire ecosystem of models aimed not just at text generation, but at robotics, science, and medicine. Industry insiders suggest that Google is already experimenting with new architectures that may eventually replace the classic transformer model and move closer to mechanisms resembling human-like reasoning. Neural networks are increasingly permeating everyday life. Even people far removed from technology are now openly admitting that they use AI, including for work-related tasks. The progress is enormous, but it has also created a strange side effect. We've become spoiled by it. Even the release of a record-breaking model no longer causes the same excitement that accompanied the launch of the first version of ChatGPT. For most people, it no longer matters whether the model is DeepSeek 3 or 3.2, as long as it can explain a recipe, help with homework, or generate a decent answer. Few care about the version number. What matters is that the model finally shows 5 fingers on a hand instead of 6. Yes, models are steadily improving at programming, mathematics, and scientific reasoning. But for ordinary users, this progress is largely invisible. It mostly matters to specialists. And that, in turn, suggests that the focus of AI development may begin to shift next year. We will likely see continued growth in assistants embedded directly into browsers and mobile devices, and hopefully something more interesting than simply booking a table at a restaurant. In the corporate world, AI agents may begin to integrate more deeply into CRM systems, task managers, and internal workflows, handling at least simple operations autonomously. In 2026, we can almost certainly expect better models of reality understanding, especially for following complex user instructions online. I'm also confident that new mechanisms will emerge to expand context windows while simultaneously reducing hallucinations, enabling truly long conversations without a drop in response quality, a problem that still hasn't been fully solved. We can also expect major improvements in video generation models, higher quality, better temporal consistency, and, most importantly, much longer videos. In general, progress in programming and scientific reasoning will continue. This won't just accelerate software development, it will also speed up the work of AI researchers themselves. And within another year or so, we may see several meaningful scientific discoveries or even mathematical proofs produced with the help of neural networks. In theory, this is exactly how the cycle toward a technological singularity begins. I don't believe the time for mass adoption of household robots has arrived yet. However, this doesn't rule out the appearance of simpler and more affordable robots for private users as early as 2026. And, of course, data centers will continue to multiply, while governments around the world will likely respond with an increasing wave of regulation. Thank you for watching, and for those of you who are subscribed to the channel, we'll definitely see each other in the next videos.